Greetings, greetings, greetings. Welcome to week 2 lecture video. This is CSC 530, Algorithms and Data Structures. Okay, we're going to be jumping in week 2. This week we're going to be concentrating on various, these are data structures and algorithms. Specifically, we're talking about lists and stacks and trees. At the end of this week, you should be able to explain the structure and the operations of a list and of a vector, and how that's implemented in C++. Implement and analyze stack operations using C++. Implementing and analyzing queues. Okay, defining trees and the transversal methods. Pre-order, in order, post order, and then this concept of STL as far as the language library, standard language library. We're going to be looking at that, what's in it, when we might use it, how it can help us as far as algorithms and data structures. Okay, so week 2 at a glance. Lists, vectors, dynamic arrays, linked lists, common operations, stacks, LIFO structure, last in, first out. You'll hear that a lot. In-queue, D-queue operations for adding things and taking things off of a queue. Trees, tree structures, transversals of trees and applications. Set maps, order collection, unique keys, efficient processing. And data structures overview, with lists, stacks, queues, and trees. These are all storage methods. Okay, these are storage methods that we can store information. You'll be using one or more or all of these in either your homework assignment, your quiz, or in your project. Okay, so list is a sequence of elements in order. So sequence of elements in order. And in order means that they came in a certain order. They maintain that order. Okay, sequence of elements in order. Stacks, last in, first out. If I have a stack of objects and I add something to the stack, when I pop something from the stack, it's going to be at the top. So the last thing in is the first thing out. That's last in, first out. That's the concept of LIFO. The concept of FIFO are queues. Okay, in that particular case, first in is first out. Okay, first in is first out. So the first thing I put in is at the bottom of the queue. Next thing is on top of that. Next thing is on top of that. Whenever I ask to give me the first item in the queue, it's going to give me the one that's at the bottom. Okay, that's what it's going to give me. That's the last in. Okay, it's the first out in stacks. Okay, and I'm going to back up here because I just told you something wrong, but I'm sure that you guys caught it. Okay, that the fact that we say that a list, okay, is last in, first out, is LIFO. Okay. The last thing that we put in is where? It's at the top. FIFO, the first thing we put in is at the bottom. Okay, so the first in is at the bottom, the first out is at the top for queues. For stacks, the last in, which will be at the top of the stack. Okay, then it'll be the first out since it's at the top of the stack. Trees, hierarchical trees, hierarchical structure with nodes, starting with a node at the top, which breaks down into one or more nodes. Basically, this is the concept that we are using when I mentioned when we were talking about a binary search, where depending on which side we go down, okay, we in essence eliminate half the tree. Okay, so what if I'm transversing something? I don't have to go through every node because using a tree hierarchy, it eliminates at least half of those objects each time I do a recursive. Okay, we talked about a recursive access of a tree. Okay, the common operations for each one, you can have lists, stacks, queues, trees, and sets. Okay. Okay, for a list, I insert into a list and I delete from the list, and I can search the list. And then I can transverse the list, which is basically I'm just going to read. I'm going to start with the first item in the list and transverse the list until I read the last item in the list. Insert, delete, search, and transverse. For stacks, we push things on the stack, we pop things from the stack. We peek to say, what's the next thing I'm going to be reading? And the concept is empty. So I can have a queue, I can have a stack that says, is there anything in the stack? That is empty. For queues, we have queues are just that we enqueue something. We enqueue it to the bottom of the queue, and we dequeue it from the bottom. Okay, so we have a front. Okay, what's in the front of the queue and is empty are things that we can associate with the queue. For trees, we can transverse a tree, we can search the tree, we can insert and delete items in a tree. And sets and maps, we can insert something into the set. Okay, we can find something in the set, we can erase something in the set, or we can iterate all items within the set. So these are the basic functionalities that's associated with each type of list, each type of data structure. Excuse me. For each type of data structure: lists, stacks, queues, trees, and sets, maps. So vocabulary, giving a more formal, quote unquote, definition. A list or a vector is a linear collection. Let's see if we can make this a little bit larger. Okay. A list vector is a linear collection of elements stored in contiguous memory in a vector, or linked nodes are linked nodes. Okay. A linear stack is a linear structure where the last element added is the first one removed. That's a LIFO. And if you think a stack, I put something on the top of the stack, and I have another one, I put it on the top of it, another one put on top of it. Okay, so the last thing that I inputted, and it's at the top of the stack, that's the first thing out. LIFO, last in, first out. In a queue, it's a linear structure where the first element added is the first one removed. So in a queue, basically, think of it as that you're accessing information from the bottom of the queue. So I add 10 items, I add item 1 through 10. When I say DQ, give me the last entry, it goes to the bottom of the queue. And from the bottom of the queue, it gives you that first element at the bottom of the queue. Okay, the first thing that was into the queue is the first thing that's out of the queue. Okay, SDL containers, they store unique sets or key value pairs, for example, a map in sorted order. Okay, so it will be in sorted order. So when I put something in a set or a map, STL, we'll talk about that here in a little bit. Okay, then I put it in order. Why does this matter? Okay, the structures are essential for building efficient, scalable, and maintainable software. They help improve performance. They model real-world scenarios. Excuse me. Okay, it's my printer. They model real-world scenarios. They write cleaner code. Okay, use the right tool for the job, and essential for advanced topics, graphs, heaps, and more that we'll be talking about later. So these basically lay the foundation. And depending on what you're trying to do, okay, you'll either pick to say, I'm going to put my list of stuff in a stack. Oh, no, it needs to be put in a queue. It needs to be put in a tree. Depending on the characteristics of what you're trying to accomplish, that is what's going to kind of drive you to determine which structure you want to use for your particular implementation. Okay, everyday examples. If you had a to-do list, okay, basically, depending on how you would do it, probably your most important to do items at the top. Okay. The lesser items are at the bottom. Okay, so that would be a to-do list, a list type concept. Stacks, a stack of plates or a stack of books. Okay. I take it, each particular item is stacked on top of the other. Okay. In a particular case, the stack, the last in will be the first out. There'll be a LIFO. Queues, people waiting in line. Okay. Okay, you got the grocery store, and all over the grocery store, you see people in line. People are getting queued up. Okay. But the last person that was that's basically going to be at the front of the queue is the first person that's going to be served. So the last person in is the first person out. That's a queue. And then trees, like a file system, we do this sort of thing when we do our C++ programs. We create a CSC530 library. From that, we create other libraries for each program that we basically are building. And within that particular folder are the individual components for that C++ program. So that's basically a tree type information that we would be implementing. And then sets and maps, dictionary, phone books. Okay. The person I want to get their phone number, last name starts with S, Stedman. Okay, so I will basically use that set. Okay, find the S, and from the S, it will distribute everybody with the last name of S until I find the particular one I'm looking for. So that's again a set type thing where everything with the same last name initial basically are put in a set of information. That would be an example of a dictionary or a set. Looking at a C++ implementation example. Yes. Okay. So looking here, this is C++ initiating or creating a vector. This is creating a stack in C++. This is creating a queue, tree, basic tree, and a set map. So these are examples of the codes. You might want to just kind of take these, put them in the back of your stack that say, hey, okay, I need to do a vector, I need to do a stack, I need to do a queue. Here's how I do that implementation in C++. Okay. Again, if you use these, what you're going to be doing is basically giving an example, not example, but highlighting the lines of code as to what they're specifically doing. Okay, here's an example of a walkthrough. Let's start out with a empty stack. 10 arrives, so I push that 10 into the stack. Okay, I had 20 arrives, I push that in the stack. So what I have is 20 and 10. Okay. I take the top of the stack, and I output it, okay, with the pop. So that particular thing that was at the top of the stack is 20. Okay. The last thing in, first thing out, not first thing out. That's a LIFO. And then here I do another pop. Okay. And here I would then get the 10. So I inputted 10 and 20. I outputted 20 and 10. Okay. That would be the characteristics of a particular voice stack. Things that commonly you need to be aware of. Look at this, for getting a base class. Again, some of these things are recursion. Okay. So in the example of again, binary search, it's recursion. I'm taking half. I'm looking for that. I take for that, and I take half. That's recursive. Anytime you're using a recursive process, you have to keep in mind, what is my base class? What is it that's going to stop and say that I'm finished? Okay, so that's what it's saying here. You're forgetting your base class. Reversing order, confusing LIFO with stack, and FIFO with queue. Okay, not knowing which one goes with which. Okay, so in the case of a stack, I know it's last in, first out. When I'm looking at the queue, it's first in, first out. Incorrect pointers, more common with linked lists and trees. where I'm pointing to the wrong thing. You need to be careful with that in C++. And using the wrong structure. I should be using a queue, but I'm using a tree. I should be using a vector, but I'm using a stack. Okay. Basically defining what you need to do, and based on what you need to do and the sequence you need to do them, selecting which particular structure works best for what you're trying to do. That is your goal in writing code. So you're getting ready for the quiz, the homework, and all that good stuff that you're probably already started on. But what is the main difference between a stack and a queue? Why does LIFO what does LIFO mean and what does FIFO mean? Give an example of a tree in real life. Why are vectors more efficient than linked lists or random access? And what is the difference between the set and map in the STL? Okay, so those are the things I want you to look at. We're not going to go through them today, but these are the things that concentrate that says, hey, I know I need to know this. So let's go ahead. I need to do some more research. Look it up. Okay. Put it in your notebook. So if you ever have to refer back to it, you instantaneously have that information available. Okay, so that's where we are. We got week 2. Again, looking at the highlights in the foundation for lists and vectors, stacks, queues, trees, and sets and maps. Okay. Part of the STL. Okay. Okay, so that's basically it as far as the overview for week 2. You're basically having a foundation. Might have to look up some stuff. I always put stuff in here that it's not obvious, so that you have to look up. Because then when you get out, and you hear me say the real world, there are going to be instances where you're going to come up against something that you're not going to know exactly what it does or what it means. My expectation is you will research that. Look it up. Say, hey, what is a queue? What is a vector? Okay. And other things, here's my situation. Is it better for me to use a vector, or is it better for me to use a set? Okay. So that kind of research is is basic to the foundation of what we're doing in this particular section in week 2. What they are, here's how they work. Now, based on what I have to do, which one do I pick? Okay. There it is. That's for week 2. We'll see everyone on Thursday. And hope you have a great rest of the week.